Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 2, part of a whole as a percent. Okay, so we have a part, we have a whole, we have a percent. Those are the three things we deal with. So we have an equation, part over whole equals some number over 100, because percent means out of 100. Okay. So we're going to keep this in mind here. Part divided by whole equals some percentage or some number over 100. So 15 is what percent of 90? So 15 would be a part, 90 would be a whole, and we don't know the percent. So the whole is 90. What number is 10%? There's my percent of 56. That's my whole. Some number n, I will say, would be a part. Okay, I use p for percent. I can't use p for percent. Let's use the percent symbol. So what number is 10%? That's percent. This is the part. This is the whole. We use a variable n. So part, percent, whole. We're asking for the whole unit. We're taking it out of a total of 56. Here's my percent. 90% of a number. 90% of some number, some total, is the part, 180. So the whole here is a number. Some number we don't know. Okay, a bag of candy contains 300 pieces. That is my whole. Here's my percent. Of the pieces in the bag are red. 25% of the pieces in the bag are red. That is my part. So my whole in this case is the 300 candies. 70%, there's my percent, of students earned a B on the test. Of the students, that's the whole. Ones who got a B was the part. So the whole was all students. Okay, and finally the last one. 20 girls in class represented 55% of the students in the class. So this is a part of the class. This is the percent. And the students in the class was the whole. So the whole unit was all students in that class. Okay, part B. Read each problem and complete the table. Record what you know. So I would look at this and I'd say 40% of the students on the field trip love the museum. So that's my percent, so I'll put it here at 40. If there are 20 students on the field trip, all the students, that's my whole. If there are 20 students on the field trip, I would go here. How many love the museum? So if I to not make this confusing, I'll use a percent symbol there. And the part is number that loves the museum. Okay, so that we don't know. So let's just put a question mark there. So we're trying to solve these. So let's just use question marks for part B. Okay. 40% of the students on the field trip love the museum. There's my percent. So I'll put 40%. I know the percentage. If 20 students love the museum, so it says 40% of the students love the museum. If 20 love the museum, that is my part. So that is my part right here. So that's 20. How many are on the field trip? That is my unknown. Okay, 20 students on the field trip love the museum. If there are 40 on the field trip, what percent love the museum? I don't know the percent, so that'll be a question mark. The part would be 20. And the whole would be 40 students on the field trip. So there's always an unknown somewhere. We try to find it by using the equation. Part over whole equals x over 100. Okay? So, example 1 says, in Ty's math class, 20% of the students earned an A on the test. If there were 30 students in class, you got an A. We'll start by doing a tape diagram. Okay, this represents all of the students. So this is the 30 students. And then it says 20% earned an A. So 20%, 40%, 60%, 80%, 100%. So this is 20% right here. Those were my A's. B, C, D, F maybe, but we don't know how this is split up, so I won't say that. And we want to know how many received an A. So I'm going to do the formula. Part over the whole equals some number over 100. The part we don't know. So I'll actually I don't want to use an X here. Part over whole equals percent over 100. So I don't know the part. That's what I'm trying to find. The whole is 30. I want that equal to 20%. Remember, percent is out of 100. That means 20 out of 100. 20% over 100. So we have this proportion. Two ratios are set equal to each other. It's called a proportion. And in order to solve this proportion, we cross multiply. So x times 100 is 100x. 30 times 20 is 600. Divide both sides by 100, and I solve for x. Zeros cancel, 6's cancel, 6 over 1 is simply 6. There were 6 students who received an A. Let's spell. Okay, 6 students received an A. Exercise 1. Now it's your turn. Try this. It says in Ty's art class, 12% of the Flag Day art projects received. 12% of the flag art projects received a perfect score. There are 25 art projects turned in by Ty's class. How many of the projects earned a perfect score? Identify the whole. So, 12%. Flag Day art projects, okay, there are 25, that is the whole. 25 art projects is the whole. How many art projects earned a perfect score? That is the part. So if I do part over whole equals percent over 100, the part we don't know, the whole is 25, the percent is 12. Cross multiply, we get 100x. I always multiply the one that has the variable first, so my variable is on the left. I always like my answer to say x equals instead of a number equals a variable. So if I multiply the variable first on the left, then it will stay on the left. And then 25 times 12 is 200. Is 300. Okay. And to solve this, I need to divide by 100. When I do to one side, I do to the other. 100 divided by 100 is 1. 1 times x is x. Zeros cancel, zeros cancel. So 300 divided by 100 is 3. How many of the projects earned a perfect score? 3 projects earned a perfect score. Okay? Example 2. In Ty's English class, 70% of the students completed an essay by the due date. There's my percent. There are 30 students in Ty's English class. What's my total? How many completed the essay by the due date? That is my part. So I'm going to write a formula. Okay, always write the formula. Part over whole equals percent over 100. The part is the unknown. The whole total is 30. I don't know why I used a T. That's a W, the whole. Equals percent over 100. Always multiply the x's first. So 100 times x is 100x. 30 times 70 is 21 and 2 zeros. Divide by 100. And 100s cancel and get x equals 21 over 1, or simply 21. How many completed the essay by the due date? 21 students. Do it again. It's T-U-D-E-N-T-S. Okay, so 21 students completed it by the due date, and then we can easily tell who did not. 30 minus 21, 9. We're late turning it in. Okay, example 3. A bag of candy contains 300 pieces, of which 28% are red. There's my whole, my percent. And there's my part. How many pieces are red? Which quantity represents the whole? 300. Which of the terms in the percent equation is unknown? The part. Define a letter variable to represent the unknown quantity. I always just simply use P. Okay. Write an expression using the percent and the whole to represent the number of pieces of red candy. Part over whole. Write an expression using the percent and the whole to represent the number of pieces of red candy. Okay, so I don't want my equation here. It says write an expression. Okay, so my expression using the percent would be, well, percent was 28, so I'd write 28 over 100, and we're going to multiply that by 300. Okay, so here's what I'm doing. I have been introducing part over whole equals percent over 100, and this is just percent, 28 over 100, times the whole. So all I'm doing is multiplying both sides by W. And when I do that, I get P by itself, which is the part, which is percent over 100 times the whole. So I'm just rearranging this portion to give you an expression. So I have the percent over 100 times the total, and that equals the part. And that will represent the pieces that are red. Okay? So now it says to write and solve an equation to find the unknown quantity. So now I could say percent over 100 times the whole equals the part. Okay? Or part equals percent times whole. Part equals percent times the whole. So this is just a rearranging of this proportion. So if I want to know the part, it says write and solve. So I write the equation, and I substitute in my givens. I don't know the part. The percent was 28 over 100, and I want to multiply that by the whole, which was 300. Okay, the 100 and the 300 will reduce to 3. So therefore, the answer is 28 times 3. 8 times 3 is 24. Carry the 2. 3 times 2 is 6. Plus 2 is 8. So there were 84 red candies. 84 is 28% of 300. Exercise 2. A bag of candy contains 300 pieces, of which 28% are red. How many pieces are not red? Be careful. That is the part in this case. Write an equation to represent the number of pieces that are not red. Okay. So the equation would be part that's not red. Okay. 28% are red. What percent are not red? So we have to be careful here. Remember, percent is out of 100. So if I have 28 out of 100 that are not red, and I have to have a total of 100, so what plus 28 will give me 100 over 100, which is the total of 1. And so it's 100 minus 28, which is 72. 28 plus 72 equals 100, and that would give me the total in the bag. So if 28 of the 28% are red, that means 72%. Okay, so I don't want to use this 28 in my formula. I want to use the 72. So an equation to represent the number of pieces that are not red, N. So now they're also telling us to use the letter N. I'll say N equals, let's write an equation. N equals the percent 72 over 100 times the. So now when I solve this, it says use your equation to find the number of pieces of candy that are not red. Okay, I'll put that down here. So I have N equals 72 over 100 times 300. And then if I cross out 100 and 300, I'm left with 3. So it's N equals 72 times 3. 3 times 2 is 6. 3 times 7 is 21. 216 pieces are not red. Okay, now it says Jalil told his math teacher that he could use the answer from example 3 in mental math to find the number of pieces of candy that are not red. Explain what he means by that. So if I go back to example 3, right here, he used mental math. He said, well, there were 84 red candies out of that same 300 bag. So what Jalil's saying is he was going to take that 300, subtract 84, and get 216. And that is what I had here. So if you already know how many are red, the rest have to be not red. So just subtract that from the 2. That's what you do. Okay, example 4. Zoe inflated 24 balloons for decorations at a middle school dance. If she inflated 15% of the total, so this is the part, 15% is the percent, the total is what we don't know. How many balloons are there total? Solve the problem using the percent formula and verify your answer using a visual model. So the percent formula says percent over 100 times the whole is the part. Okay, and let me write that the other way. Start with P. Part equals percent over 100 times the whole. I'm trying to solve for the part. Actually, it says how many balloons are there total, so I don't know the total here, but I can still use this formula. P, the part, is 24. The percent is 15. And the whole is what we don't know. I don't need a parenthesis there, so I won't write the parentheses. So 24 equals 15 100ths W. Now remember that when we want to get rid of something, and that's multiplication, the inverse of multiplication is division, but when we have a fraction, the inverse of a fraction is its reciprocal. So I'm going to multiply both sides by 100 over 15. The 15s will cancel, the 100s will cancel, and we get 1 W. And I multiply this by 100 over 15, and I get 2,400 or 2,400 divided by 15. So W is going to equal 15 goes into 24 once, with a remainder of 9, and 15 goes into 90 6 times. Okay, now when I'm done, I get an answer for 16. This is a common mistake right here. I paused for a second because I honestly forgot to do one thing. But whenever you're finished with a problem, you can always go back and see if it makes sense to you. So it says Zoe inflated 24 balloons, and that was 15% of the total. What's the total? Well, if I have a total of 16 balloons and she inflated 24, that's not possible if you only have 16 balloons. So what am I missing here? I'm missing the 0. 2,400 divided by 15 is 160, not 16. Now that makes more sense. 24 balloons is 15% of the total. This better be less than your total, obviously. Part can't be more than that. Okay, example 5. Haley is making admission tickets to the middle school dance. So far, she has made 112 tickets, and her plan is to make 320 tickets. What percent of the admission tickets has she produced so far? So this is the part, this is the whole, we don't know the percent. So part equals percent over 100 times the whole. So in this case, I know the part is 112 equals x over 100 times the whole, 320. Substituting my part, substituting my whole. This time I didn't know the percent, so I used a variable x. Okay. I'm going to if I have something times a number, the inverse is division. So if I divide this side by 320, I divide this side by 320, these cancel, I get x over 100 equals 112 divided by 320. I'm going to reduce that. I know they're both even, so I'm going to cut them in half. Half of 11 is 5, half of 12 is 6, half of 3 is 1, half of 22 is 11. So that half of 320 is going to be 160. She's a half of 12, 6. And it's still both even. So I'm just doing some reducing here. Half of 56 is 28. Half of 160 is 80. They're both still even. 14 over 40, still even. 14, half of 14 is 7. Half of 40 is 20. So that is as low as I can go. So I'll write 7/20. Okay. I could have left it this or this. It would give me the same answer, but my number would be larger. So now when I cross multiply, I get 20x equals 7 times 100, which is 700. Divide by 20, divide by 20, 20's cancel, x equals 70 divided by 2, or 30. And answer the question correctly. What percent? 35% of the tickets have been produced. Okay? I'm not going to do the visuals in the video. That is the end of lesson 2. Go to your problem set.